Greetings, everyone. Welcome to the final plenary session. I'm going to start with a panel session on the water, energy, and food nexus. My name is Chris Justice. I'm the co-chair for the GEOGLAM Agricultural Monitoring Initiative within GEO, and I'm chair of the Department of Geographical Sciences at the University of Maryland. So we can all intuitively see that there are connections and interdependencies between water, energy, and food. And these are addressed explicitly by the water, energy, food nexus concept, which we call the W-E-F. The W-E-F Nexus concept first gained visibility in 2011. Approach to resource management and planning. Since that time, several W-E-F-focused projects and initiatives have demonstrated the utility of the concept and the approach. The W-E-F Nexus becomes increasingly important in the context of limited availability of land, water, and energy, which we're experiencing in many parts of the world, and the need to establish water, energy, and food security. So addressing the impacts of climate change and mitigation across the three sectors and meeting the sustainable development goals add further challenges, but policy relevance to the whole water, energy, food nexus. So the GEO Work program has initiatives across the W-E-F Nexus, suggesting a significant potential to address the GEO priorities in a more holistic way. However, to date, the initiatives rarely, if ever, work together in an integrated way. So the purpose of this session is to start to look at a few work plan activities and explore the opportunities for greater integration and identify ways in which GEO can help encourage the Nexus approach. So that in this session, the GEO Secretariat has invited 3 short presentations: an overview from the EO4 W-E-F initiative, programmatic perspectives from 3 GEO initiatives, GEOGLOWS, GeoCradle, and GEOGLAM. And this will be followed by an open discussion with comments and questions from the audience. And if you have questions and comments, please put them in the Q&A box. So the goal of the session is to identify near-term opportunities for applying Earth observations to the Nexus and expanding such activities through the GEO work plan process. So our first panelist is Rick Lawford, and Rick has worked with the Canadian Meteorological Services and NOAA. He was the program manager for the GEOEx GSIP and GAP projects and served as the director of GEOEx. He has been involved in GEO since 2005 and is currently the co-lead of a future Earth project in the W-E-F Nexus and the lead for the GEO4 W-E-F initiative within GEO. So Rick, I'd like to introduce you and see your 8-minute presentation. Thank you.
Thanks, Chris. Can everybody see this?
Yes, that's good. Thank you.
Okay. So I'm going to try to give a little overview of the landscape of the W-E-F Nexus. Chris has already introduced it very eloquently, but I'll just elaborate on a few of these points. The W-E-F Nexus offers a framework for looking at a wide range of issues that affect water, energy, and food security in a more integrated way. We know that water, for example, influences energy and is influenced by energy. Water influences food and is influenced by food production, and energy is required in food production. And as we move towards biofuels, the productivity of the landscape is going to be more important for energy usage as well. So why would we want to pursue this W-E-F Nexus? Well, it has a number of uses: resource assessments, planning, managing, protecting the environment, reporting on the progress of resource development, advising, governing, These are all things that are the result of application of the W-E-F Nexus. Now, what we need is a way to be able to reduce or soften the boundaries between the W-E-F sector silos. Ministries tend to be very self-sufficient and not necessarily interact with each other, and that's true of food, water, and
Rick, the sound has gone away. Nope. Maybe you pulled the plug or something.
Yes, we've lost it. Rick, if you're listening, we've lost your sound.
Okay, I think I found the problem.
Good, thank you.
Let me move to the next slide. Agriculture and water energy use. As you are aware, in the water sector, approximately 70% of water consumed worldwide is used for food production, and 35% of the energy produced globally is used for food production, processing and distribution. FAO estimates provide that information. So it's clear that to address food production, we have to secure water and energy and make that available for a continuation of the current processes. In the past, we've produced very productive systems for making food available. The Green Revolution was an example of this. Farmers in northern India were allowed to have unlimited access to free electricity for pumping groundwater for irrigation, and they did that, but there were consequences for the environment, and consequences that could be seen by a rather coarse resolution satellite, the GRACE satellite, which monitored the groundwater depletion that occurred as a result of that high level of groundwater use for the Green Revolution. Again, that's seen in other parts of the world as well, but it's an evidence that we need Earth observations to monitor the implementation of the W-E-F Nexus. The UN, as you know, proposed 17 Sustainable Development Goals, and they had targets and indicators for each of these goals. Those goals provided a framework for looking at many social and environmental issues facing humanity, and they're being pursued quite vigorously by many countries. Three of those goals deal with the water, energy, food nexus components. Goal number 6 is water, goal number 7 is energy, and goal number 2 is food, and gives a number of targets to be achieved by 2030. Now, if we look at those targets and do a cross correlation, as has been done by Feder and al, using an environmental services index, one finds that there are some targets that are synergistic and are mutually supportive of each other. And so if you achieve one of those targets, you achieve many of the targets, or you contribute to many of the targets. Others are neutral, or perhaps in some cases, they're even working against each other a little bit. So if we look at target 6.5, which is a water target for the implementation of integrated water resource management, we find that there's a lot of synergies with it, indicating that integration in these three sectors, water, energy, and food, can bring a large number of advantages. And Earth observations can help because the targets themselves are endpoints, but the actual process for achieving the target requires the W-E-F Nexus concepts, and it also requires Earth observations to achieve it. So if we develop Earth observations for the W-E-F, they'll be of benefit to these three goals as well as others. Climate change is another issue. Long-term drought currently is gripping the West, and that's anticipated to be a major problem for the United States as climate change goes forward. we need a two-pronged approach, and that's actually what's evolved. One that includes adaptation, and strategies are needed to address things like the new thermal patterns that are going to result in summer and winter heating, new precipitation regimes and extremes, rising sea levels, particularly in coastal areas, and Earth observations and information are essential for monitoring those trends and establishing adaptation strategies. And of course, if we can develop strategies that serve three sectors, not just one sector, they'll be much more efficient. On the energy side, mitigation, as pointed out by Pietro Campana, a colleague in the EO4WEF community activity, as we move towards more renewables and green energy and set aside fossil fuels, we'll have to rely on things like wind turbines, bioenergy, hydropower, and more eloquent systems like floating voltaics or photovoltaics for water pumping, or agrovoltaics, ways of combining agricultural production and the use of the land for photovoltaics at the same time. Again, for siting and planning and operating these renewable energy systems, we're going to need Earth observations. So there's a great role for Earth observations in this mix. It's a matter of finding the entree points. And here's a proposal for an information system for the WEF. First of all, we have to define exactly what's in and what's out of the WEF Nexus. And that's not a simple task. Identify what the essential variables are. And this is just a listing of possible variables, but you can see that many of these variables are actually being used in all three of these sectors. It's a matter of finding the type of resolution, the type of frequency of observation that meets all of these needs. Once we have this set of data, we can co-design products with users. We can develop a multidiscipline information platform, develop prediction and scenario development capabilities, and facilitate adoption by governments and producers of the system. We need to do this clearly on a regional basis, or even finer scale on basins, and test basins would be a way forward. The WEF Nexus community could also benefit by following the SDG model of targets and indicators, and that would help in reporting progress to indicators. So just to sum up here, the WEF Nexus provides an opportunity for GEO to demonstrate its service capabilities and data principles, and to promote integration through data use. We do have a community activity for EO4WEF. It's a small activity, but we would be glad to participate in any coordinated effort that GEO might have. We're seeking to develop test beds to assess integrated data services and analytical tools by interactions with stakeholders as well as with the providers. It also brings the community together to plan meetings, scientific sessions, and special journal issues. Future Earth has a knowledge action network that supports the Nexus projects in different parts of the world. And Chris made reference to a recent study that was done. This study has identified some areas where it suggests action is needed, including the development of a WEF definition and a typology of terms that all sectors understand and relate to, a review of the information requirements and research needs, an assessment of gaps in observational systems, and the need for a high-level international summit to increase interest and commitment to this approach. And that's maybe something GEO and FAO and other agencies could move forward with. But I think that's an important tool for getting commitment at higher levels. Thank you.
Great. Thanks, Rick. Much appreciated. Our next panelist is Alice Andral. She's the Hydrology Application Lead for CNES, the French National Center for Space Studies. She co-leads the GEOGLOWS Water Sustainability Initiative within GEO, and is a member of the Terrestrial Observation Panel for Climate under GCAST. So, Alice, you ready to present?
I cannot share my screen right now because it seems that's small.
you're not authorized. Rick can share it.
Okay, excellent. I will share it now. This is a presentation mode, or
You can click on the PowerPoint presentation mode, either at the top or at the bottom. Great.
just a moment. A bit better now?
Yes. Thank you.
Okay, I will try. It's not the beginning. Sorry for that. So thanks, Chris, for the introduction, and thanks for having me. So I will try to talk about water in this water energy food nexus and focus after on GEOGLOWS activity. Before starting with GEOGLOWS, I would like to remind you some challenges about water, because I think we all know that water is a scarce resource. For domestic use and for the everyday life, it is essential. And we see on this little image that the little blue dot we see here is the fresh water we have from lakes and river. And there is no substitute to water. It is definitely a critical input to any economic sector, obviously agriculture and food and energy, but also transportation, manufacturing, tourism, and domestic use. And it is also a driver for a sustainable economic development and poverty reduction. It has impacts on health, education, migration, gender equality, and geopolitical rivalries. So it's definitely something precious. And it's also a fundamental human right, as Rick already told you, within the SDGs. It is often considered that the water is a backbone to support the implementation of the SDGs, because without solving the problem of water, it's difficult to solve the problem of poverty, of hunger, and so on. So definitely water is cross-cutting and has influence over all sectors. It is also a resource that is definitely under pressure. We have a growing in population. We should be about more than 9 billion by 2050. And if we have a growing population, it is equal to an increase in water demand. And by 2050, this increase is estimated by 55%, but only for domestic use, manufacturing, and energy. So it doesn't take into account the part for agriculture. And as we told you, agriculture accounts for 70% of water use. So we definitely expect to have a competition between the different water use, and the decision to be made will have impact on other use. And the other challenge is about biodiversity, because water is what I like to say the lifeblood of ecosystems. We know that rivers and wetlands are natural connection for species, and having dams, having intense agriculture, a change in land use, pollution, and so on, impact water and impact biodiversity. So it's something we have also to have in mind when taking decision. And the last challenge, but not least, is climate change, because for water, it impacts the whole water cycle, which becomes less predictable, and that is a real problem. We have more and more extreme meteorological events, floods, droughts, storms, and so on. So the question of how to take the right decision, knowing these challenges, is crucial. And to take a good decision, you need to have good data and appropriate data. So we often say that data is our gold, but you can't manage what you can measure. And when we look at water, we still have the difficulty today to have an estimate of the total amount of water available, and also for the water quality. And regarding the in-situ measurements, we have the issue that we have a non-uniform distribution of water. some areas are non-accessible, even from Earth observation, because it's difficult to see under vegetation. We have some problem on homogeneity and quality of the data, and this is an issue for calibration and validation of Earth observation data also. There is in some areas a decrease in the in-situ network, and the data sharing is still an issue. So for water, we have this objective of having an integrated water resource management, but it's still not necessarily addressed right now. And if we look at what I like to say, the basic water data, which is water level, at present time, we have almost 1% of water levels of lakes that are monitored, which is very, very few. And for reservoir and rivers, they are either unmeasured or are guarded state secrets in much of the world. In this map, in the dark blue points, are the data you have available after 2010 for discharge, and you clearly see that there are huge amount of areas in the world where we have absolutely no data today. So Earth observation definitely has a real added value in water management, and it comes as a complement to in-situ observation. And the aim of the GEOGLOWS initiatives, or GEOGLOWS, is for global water sustainability. We try to work to provide relevant, actionable information about water, and we promote the use of Earth observation, but also trying to strengthen the observational network in local operational frameworks. So we are working and we have defined some essential water variables. Some of them are linked with the water quantity to characterize the water cycle and the water availability from local to global. And we have also a water quality variable, because it's also very important. We share also some variables with agriculture, like land cover, vegetation, and land use, because it also has huge impact on runoff and infiltration in the soil for water. One other thing that is interesting with the GEOGLOWS is that we try to move from data to action. Because if we look at Earth observation, especially for flood areas or flood extent, we have a huge amount of data, and people often say that they are drowning in data, but they are still thirsty of insights. So to take action. So the stream flow forecasting that has been developed within GEOGLOWS is a good example on how to move from data to action. It gives access to historical stream flow. It provides also an operational 15-day forecast on every river in the world. All data are freely accessible and can be reusable in a custom application. You can access the result through an API. And so it means that you can plug your service or your application or your decision just after. You don't need any hydrological model to be able to take the fast action. So this is something very, very interesting. And within the water energy food nexus, I think it's really important to move from data to get all the possible data to essential variables, to move to indicators so that you can have information, and so that end users will have the knowledge, will understand what's happening or what happened and what will happen to take the right decision. So this WEF Nexus, the aim is really to reach a sustainable management and to have a more productive and smarter system, because there are a lot of interconnections and overlap between the different components. We definitely need to avoid silos. And the main issue and challenge is to transform observation and simulation and by saying observation is definitely all observation, Earth observation from satellite, from in situ, from citizen science, for socio-economical data, analytics in water, food, and energy, to transform this into valuable information and extract the necessary knowledge. And this is a very huge challenge we have within the WEF Nexus. So that's all for me. Thank you.
Great, thank you, Alice. Our next speaker is Stelios Casades, and he's a senior researcher at the World Radiation Center in Switzerland. He's a member of the International Radiation Committee and has been leading solar energy projects, including GeoCradle. Stelios?
Okay, thank you very much. I was asked to talk about GeoCradle and the energy perspective on the WEF Nexus. I would like to thank also Haris Kodoes, Alexia Tsuni from the National Observatory of Athens, and Philippe Blanc from IN Paris Tech for their contribution in this presentation. I'm not going to say a lot about how important is the energy in this perspective. The previous speakers have addressed a lot of this aspect that we're waiting for an increase of energy by up to 80% by 2050. Also increase in the water demand and in the food demand by 2050. So I just copied here some of the major thoughts and results of the International Renewable Association that talk about the interlinkage between the water, energy, and the food supply systems. So the Nexus consideration is a major thing in country sustainable development strategies. But the Nexus affects the extent to which water, energy, and food security objectives can be simultaneously achieved. And they point out that the renewable energy technologies could address some of these trade-offs between water, energy, and food by bringing these substantial benefits in all three sectors. Since the presentation has to do with GeoCradle, I will spend a few minutes to say what it is. The GeoCradle is an initiative of GEO, a coordination and integration of Earth observation activities, accelerating the development of links with Copernicus and GEO and GEOS. It started as a European project, Horizon project, from 2016 to 2019, and has been upgraded to GEO community activity. And it aimed to the coordination and integration of Earth observation activities in North Africa, Middle East, and the Balkan area. So you can see a figure on how this project and initiative worked from the beginning. It's based on 4 different pillars: the regional data hub, so data, the network of stakeholders, and the gap analysis of the capacity skills of each of the countries involved. And also the 4th pillar was some pilots which addressed some of the WEF related parameters. And more specifically, they addressed the adaptation to climate change, the improved food security, access to raw material, and access to solar energy. So these pilots have been working in parallel, addressing some of the sustainable development goals for the energy sector, mainly the affordable and clean energy. Now, there were a number of users that have been using these outputs, including ministries, also transmission and distribution power operators. And this initiative and project led to the collaboration with a lot of other initiatives and new projects that are ongoing, most of them. I was just mentioning SMERPS, the project Excelsior, Eiffel that just started. All these are geo-related projects. And I'll stop a little bit in the ESAID project, which is the EuroGeo Showcases application powered by Europe. This is the name, ESAID, that includes 7 showcases, including water, renewable energy, and agriculture, and climate, and 27 different pilots that address most or a lot of the essential variables that we are talking about today. Some of these pilot studies were dealing with solar energy. Was, for example, the solar energy nowcasting that transmission operators of power are using, the forecasting that also distribution operators are using, and historical data planning. For example, the Ministry of Egypt has been using this data in order to decide how and where to invest in PV energy, solar energy. In addition, there are pilots that have to deal with urban areas, and this is an example of a pilot led by Min Paritech. So you can see on the left an area at the city of Nantes, and on the bottom left, the electric consumption, how much is the self-consumed production from the photovoltaics, how much is the import, and how much is the surplus. And on the right, collaboration with Enedis, which is a distribution system operator for the area, and the exploitation of the photovoltaic penetration in the rooftop systems. So all these aspects have been addressed in these projects related with GeoGLOWS and also this new project is safe. So I will go back to the Nexus and the energy, and I put in the middle the climate change, which is really a parameter that it's very important because changes in these three parameters will have an impact on climate change, and also the climate change will have an impact on all of these three. And through the United Nations definition of the energy security, which is the uninterrupted physical ability of energy at a price which is affordable while respecting environmental concerns, we can see that also on the right plot that the energy is the most, let's say, greenhouse gas emitting aspect right now. And going back to this geocradle approach about the future, I'm not going to read everything here, but the approach was based on 5 different pillars and 3 different, let's say, time-based aspects: the short-term, the mid-term, and implementation, and the goals. And the pillars have to do with data, the Earth observation support to policies, the ecosystem capacity building, the Earth observation services, sustainability support, and the uptake. And going a little bit deeper on that, for my point of view, for this kind of projects and the Nexus, we would need a step-by-step approach. First, identifying the essential variables, then the indicators and the SDGs. For example, as an example, the essential variables could be water use, temperature. The indicators could be water use efficiency, radiation use efficiency. And these 2 initiatives, GeoVision for Energy, GeoGLOWS, are mostly dealing with the energy part right now. Then to try to adapt some novel in situ and Earth observation related solution on operational systems. And I just point out here this other initiative for Earth observation for the Sustainable Development Goals for GEO. Then to try to develop some necessary infrastructure tools. One of them is this DEA system that it's a European investment. To test the novel integrated observation system in real conditions, and finally to ensure the long-term sustainability of the solution and to maximize the impact. This is an approach, like a step-by-step approach on a, let's say, in a project-based approach. But in the last slide, I just have to point out some thoughts about future demand that is going to increase, as we said, about the future system and that are inherently interconnected. So if we want to deal with a Nexus approach and not with individual W-E-F or VEFs, we have first to understand the interdependencies across these 3 sectors and identify the actual data and actual essential variables that we are going to deal with. we have to make sure that decision-making processes are facilitating a dialogue because the stakeholders, scientists, and the people that are coordinating this kind of projects. And the most important is that, from my point of view, we need some interdisciplinary solutions. So the left figure shows three axes. One axis is the thematic layers. The second axis is the temporal scale and changes that we expect. And the third axis is the spatial scale, because there are different priorities for smaller spatial scales, for other priorities for regional scales. And the importance of these layers is different for different scales. So from my point of view, running an approach of parallel, let's say, small projects in water and energy and food related aspects would not be very useful for the Nexus, and we need to have some kind of top-down approach, meaning identify common goals and go from there down to the data into these different levels of thematic layers.
For this evening
Yeah, that's it. Thank you.
Thank you. So our next panelist is Ian Jarvis. He doesn't need too much introduction. He is the Executive Director of GEOGLAM. He's based at the GeoSecretariat. He came to Geo from Agriculture Agri-Food Canada and has been involved in GEOGLAM since its perspective. So Ian, since its initiation, Ian, you're going to give your perspective on the WEF.
Great, thanks, Chris. My screen okay?
Yes.
Good, okay. So thanks a lot for the opportunity to speak on behalf of GEOGLAM and discuss our perspective with the W-E-F Nexus and our approach to it. I like this diagram because it really shows the complexity of what we're dealing with. It links data sources and information to the various, these are just the SDGs, and this is just a little snip of it, but not the entire picture. That comes from the European Observatory of Earth Observation Networks, which is associated with the GEOEV activity and GEOEssential. So this is very interesting work, very useful, if for nothing else, showing you the challenge before us. So when we look at our little piece of the world, we see SDG 2, food security. We see things like crop type, crop yield, land cover. And we know that GEOGLAM can definitely contribute to some of those, and there's many others as well if you did a comprehensive view of this where GEOGLAM could contribute. But with all this complexity and confusion in the systems, how do we actually comprehensively contribute? And that is what I'm going to talk about, and how our community is trying to deal with this complexity, and it really resonates with almost every other presentation that we've seen. So dealing with a very complex policy environment, not just SDGs, but the climate challenges, disaster risk reduction, and so on. Information produced by GEOGLAM, as I said, we know it can help support a multitude of these policy targets. However, almost all targets and goals require information integrated across multiple science communities. There's very few of these indicators that are quite complex that just require information from one science community. This suggests there's a need for a common approach across communities to enable the integration and information sharing. And as some of my colleagues have already said, the GEOGLAM believes essential variables are a step towards this new paradigm. And it's something we've been working on over the last couple of years. So in terms of essential agricultural variables for GEOGLAM, I think everybody knows the concept. It just suggests a minimum set of fundamental variables required to characterize state and change in the system. I like to say, even though these systems are complex, there's only so many ways to slice and dice it and describe it scientifically with data and information. And if we can boil it down to those key variables, we're already reducing the complexity that we're dealing with. So EAVs are also very useful as a communication device. So we look across the GEO work plan, we see many communities have adopted this approach. As I said, it reduces complexity when faced with multiple needs. It for our community, it's really helped us to focus our activities, really become the link between our EAVs and our policy drivers, really drive the generation of information products. And then communicating GEOGLAM outputs, that's our way for our community to communicate to other communities what pieces of the puzzle we can start to provide that will support integration. And I just pulled two out, the GCOS climate ECVs here, and the GEOGLOWS, which we saw earlier from Alice as well. I put check marks beside the EVs that kind of correspond to our needs as well. And I could do this for many other sets of essential variables as well. This is a very good thing. Right now, we're somewhat stovepiped, but this suggests there's a huge opportunity to work together and collaborate towards kind of a common approach to essential variables. And this is a good step forward in addressing the Nexus challenges. I pulled this slide from Anthony's presentation from last night because it just illustrates what I'm saying quite well, I thought. On the left side, this is where we are. We have a lot of communities working on essential variables, trying to support the various policy drivers. But what we really need is to align those communities and their variables in a more systematic way to fully describe the social ecological Earth system. The question is, how do we get there? It's a huge challenge. Another thing I often say is science is really easy. It's the management of people around the science that is often the challenge. So I never want to leave an opportunity unfulfilled. I'd like to provide a possible solution, hopefully fodder for discussion later. First of all, there's obstacles to integration. I won't go into those. I think we'll be discussing them. Chris mentioned he wants to cover this in the discussion after. But what can GEO do to support integration? Certainly engage and advocate for integration. This is what GEO does so well. And we're at a threshold of a really good opportunity with the next GEO work plan coming up in not too distant future. Gives us a plan to position these activities so that we can move forward and find new ways to work across the work plan rather than in those stovepipes. Also, work in recent years with the stakeholders, FAO, UNFCCC, and so on has been excellent. So I guess the relationships with our key stakeholders are getting stronger and stronger. And this is good, and we need to continue this. Then identifying and targeting funding. This is key. Funding is key. It's the fuel that will drive a lot of the integration. And as a practical way forward, I'm suggesting we should work with the willing, identify some easy wins. We don't have to solve all the problems at once, but if we can just build a culture of working together by starting with some relatively simple, easy wins, that's the way to go forward. And I wanted to leave it with also some possible topics to drive integration. And this has been presented by others in this session as well. So there's an overlap here, but certainly on the climate intersection with the Nexus, land use state and change is something we're quite interested in. Food, biofuel, crop residue, the trade-offs around all this, with in terms of climate change, UNFCCC, global stocktake, and nationally determined contributions are areas that we can work in an integrated way to support. Then the other one is the water availability, allocation, quality issues across the Nexus. Reservoir height, it speaks to not just water, but to energy through hydroelectric use, agriculture through irrigation, aquatic ecosystem health as well. And it all plays into the access to groundwater, the Indians situation where deep aquifer mining, if you like, is taking place, requiring incredible amounts of energy, this sort of thing. So there are lots of things we can work on. I think the important thing is just to get started and to start finding mechanisms to allow us to work together, find some good common challenges to address together and get moving. With that, I'll stop and I look forward to the discussion.
Great, thanks, Ian. That's so I think each of those presentations has really just pointed out that a lot of the it's an obvious thing that a lot of aspects of our society are connected, and the way that we organize our institutions to address those, it presents an obstacle to that kind of integration, to deal with the connections rather than the individual elements. And so I think we've got some obstacles, I think, which we should talk about to moving forward. I think we're all in agreement that there are connections. This nexus is simply connections or linkages. And there's been some comments in the chat supporting that. But how do we've got 15 minutes, so we need to be efficient. So there's a question that came in on the Q&A from Jai Parahar. Maybe I can ask Stelios to respond to that. He could type an answer in. The next anonymous attendee suggested that the SDGs themselves are all connected, and there's a nexus, of course. And can we talk about connectedness or the nexus of the SDGs? Yes, I think we should. As I said earlier, I think that the way the SDGs are being addressed is really an institutional issue that we need to deal with. There's a further question from Laurent Durieux on the relationship between rainfall, precipitation, clouds, and land use, and deforestation, reforestation, and hydrology. So yes, there are components of that system which are also connected. And a final comment in the question in the Q&A from Hans-Peter Plug, which I think is really a good one, which is, where are the socioeconomic variables that are required in all of this? If you look at the variables people are suggesting, they tend to be physical, almost like following the ECV climate variables. And I think that what we've got to be looking at is then the socioeconomic variables that are either driving this or impacted by this as well. And so I think it's an expansion of that whole discussion into what measurements are needed to inform. I would open up the discussion on obstacles to the panel and ask maybe Alice, do you have some suggestions about what are the biggest obstacles to moving forward on this integration?
Yes, I think that the first one is that we are facing sometimes a problem of accessing the data, because some data are not open. Especially if we look at water, having the information of the management of a dam is really important for hydrological models, and we don't have access to that. So having open data will help to understand the interconnection between the different sectors. And it's also, we have also to make the effort to have model and tools that are open source, because behind that you have you need to have a user engagement, and they need to trust the data. And the fact of having the data open is one element, and the other obstacle I see, and that we need to have trust on the data, and we have to manage the error of the data. And this is something very difficult to have, because we know that we have uncertainties with Earth observation, we have uncertainties with modeling, and if we look at future climate scenario, we also have had some uncertainties, and we really need to assess that to have a sustainable and trustable data. So open source data, having access to the error and the uncertainties, to help to have a real user engagement. So that is the main for me.
Thank you. Let me be the devil's advocate a little bit here and shake things up. I mean, it seems to me that we have elements and initiatives within GEO that are addressing the gaps and the linkages between essential variables. We have an initiative within GEO that's looking at the GEO for SDGs. So we have the structure, we have our water resources, our energy, and our agricultural initiatives. And yet we still don't seem to be able to sort of capture this these linkages in a successful way. And I think it's something that obviously in the next work plan will have to be addressed. One of the problems is that if we can get our act together in GEO, then the question is the audience for that information receptive enough to take that on board? So if we come up with common variables which are linked between these the different parts of the nexus, is the policy framework that's set up receptive to this kind of input? That's an open question. Rick, do you have any thoughts on the obstacles?
Yeah, I do. I think one of the problems is that we don't have a large enough pool of people working on some of these problems. And part of that is that there's not a big enough investment to make it attractive. Integrated science or multidisciplinary science is hard to get funding for because NSF and other programs tend to be pretty specific in funding a discipline. So moving to a multidisciplinary perspective, both of funding science and investing in the projects that are done and thinking about the projects that are done is important. We all tend to drift towards our own interest, but how do we broaden that perspective? I think we need to have a challenge that brings everyone together and move forward with it. The SDGs have the potential, but they're pretty unwieldy unless you sort of stand back and think in very large terms. And maybe that's where the WEF can actually be helpful. The other obstacle is that when you come to an agency or a ministry in a state government or a provincial government and say, we're here to help you, we're going to bring together all your water activities and energy activities and food activities, you immediately meet with resistance. You have to find a way of moving slowly and a way that it brings them cooperatively into the program rather than having them view you as a threat. And I think that's a challenge, particularly when the governance side of issues is being brought forward.
Good, thank you. There's a comment in the chat from Gilberto who suggests that we have to include the modeling community to be able to really represent and study the nexus, and I agree with that. The question is that the modeling community is very, very broad, and I think the idea of having modelers be more integrated is something that's been around for a while, but the scale at which they work is probably not the scale at which we're talking about in terms of addressing some of these questions at the local to national scale. So we need to think about what parts of the modeling community come together in a new way, a sort of more innovative approach to the modeling. Another question from in the chat, another comment was that Tony Lehman put in a linkage to addressing essential variables within a fuller socio-ecological system. People can perhaps look at that. If you put it in the Q&A, everybody could see it rather than in the chat. Ian, do you got any comments on the challenges that you've seen?
I think I'd echo a lot that's been said. I think structurally we need leadership, both within our communities and within the GEO overall to pull things together. And that doesn't really exist. Then institutionally, in the sense of GEO institution, we need mechanisms to promote that kind of integration. We don't have that yet. And then, as I said earlier, funding drives it all. And Richard pointed out that the access to funding for integrated work is lacking, but we really need to, that's why we need the leadership, we need to be organized, and we need to go after it. And we need to bring the policy community, our stakeholders along with us for a ride. As was pointed out, we can't go to them with solutions at the end and say, we solved all your problems. We need to bring them along, work with them to develop the solutions. Simple as that.
Thanks. there's a question from Meredith to say, how do you promote funding for interdisciplinary science when agencies are appropriated funds separately for specific programs? I think that's a rhetorical question, because it's that's the way the funding is set up. I mean, there are a number of initiatives to try to fund interdisciplinary research, but they're relatively small within different organizations and funding agencies compared to the standard agency approach to dealing within a particular sector. Stelios, do you have a comment on obstacles that you've seen?
I don't want to repeat what Richard Lawford said, but interdisciplinarity is really what we're talking about. And for a very practical aspect, I think that even scientists that work in these three different, in W, E, and F, are having difficulties to understand each other. So I think that finding common essential variables is one option, but for me, the option is to go directly to the effects and the socioeconomic effects and try to convince people that there are no separate scientific fields, but there are three fields that are interconnected and they contribute differently in different areas. And we have to go from the socioeconomic effects to the scientists, maybe find common variables, maybe some of the variables are just for one of the three scientific aspects, but try to go this way. That's my...
Yep. Okay. Thank you. There's a question, trying to keep up with the these various questions. It's there's a question on the spatial scale of the water, energy, food demands are estimated. I mean, I think some of the most successful initiatives on the WEF have been at the drainage basin scale, thinking about the Mekong and the Nile River, where you've got competing demands for energy, agriculture, and water. And I've seen those work really rather well at that scale. But of course, that cuts across national boundaries, and then you get into the broader issue of the politics of it. It's really a sort of a compelling problem to deal with. But it's one that's getting increasing attention around the world, where water is becoming scarce, as Alice showed in her presentation. It's really becoming a critical issue, and trade-offs have to be made. Looking at any other comments on obstacles, because if not, we should talk about the way forward. I'm trying to read the Q&A. If any of the panelists could answer, type an answer in, that would be appreciated. We're not ignoring them, and we just don't have a lot of time to deal with it. We have about 3 minutes left. Talked about restrictive data policies. This is from George Huffman. As commercial sources of data become available, how can we move that to more open data policies? And I think there are attempts to do that. I think Norway has done a very good job at making data available, purchasing data and making it available. And I think we're likely to see more of those exercises coming forward. Looking at the chat. So the way forward, any last comments from the panelists? Ian, you talked about leadership. Do you have some suggestions?
I think there's things that GEO can do as we look towards the next work plan that may help bring that leadership forward. We could start to look at new ways of GEO work planning to, again, put those mechanisms that allow us to work in an integrated way more. Link those to the outreach we're doing with the priority stakeholder communities and so on. And challenge the GEO Program Board, I think, to come up with, work with us, but come up with new mechanisms to support this kind of work. We have a bit of time to think this through and put it together. I don't have the immediate answer, but.
Right. So it seems like some sort of a discussion around the next work plan on this issue of interconnectedness between these various elements. I think that would be a way to go forward. Bring a small group of people together to look at where the connectivity is and where it's working and what GEO's comparative advantages in that, in the use of Earth observation. Good. So that, I'm afraid we're getting close to the end. It's 1 minute left. Any other comments? I'm looking at all the comments and the chat. I think this has got a lot of issues here. We don't have enough time to deal with them all, but certainly I think it's been a useful session. So I'd like to thank GEO for putting this together, and I'd like to hand over the moderator for the next session to Kathy Fontaine, who's going to be moderating the next session. So thank you all the panelists for your input and keeping to time. And we just needed another 2 hours, I think, to make it a really useful session. So